Good evening, my lovely year 11s. Today I would like to move on from what we learned last time. We learned about the multiplication rule in one of my other videos. Um, so we've already talked about the multiplication rule and we talked about permutations. Um, but in this particular video, I want to talk about combinations. Um, so to actually illustrate the difference between a permutation and a combination, I'm going to take an example that we discussed last time. And this example is on the three-letter word cat. So a really simple example so that um, we can understand the concept, because that is the main thing. So in how many ways, my question to you is, in how many ways can I arrange the letters in the word cat provided I take them two at a time. Provided I take them two at a time. Okay, so what I want you to do is to try to list down all the arrangements that you can think of. And when you're ready, you can press play again. Um, okay, so if you listed all the arrangements, you would have found CA, AC, AT, TA, CT, and TC. So that gives you 6 arrangements in total. This is also known as a lot of you might already know, this is also known as AKA permutations. Keyword permutations. Permutations is just another word for arrangement. We use this symbol. If you could guess, what would its symbol be? We use the symbol. Um, if you guessed P, it's right. So we use symbol P. And if I were to write it in mathematical form, I'd say that I have 3 letters and I am selecting 3 letters and I'm trying to arrange them two at a time. So I am finding the arrangement of 2 letters from 3 letters. That is written as, for the above question, for the cat question. So arrangement of cat would be equal to 3 as the superscript P2, which is the same thing as that can be written as 3 factorial over 3 minus 2 factorial, which is 3 times 2 times 1 over 1 factorial, which is just 1. So that gives you 6 total arrangements, and that agrees with what we found here. Mathematics is all about looking at patterns and then coming up with a formula or a way to explain it, a general mathematical formula to explain it. So we just looked at the pattern and we found that the factorial notation. If we use this factorial notation, it works. So let's just come up with a general formula now. Let's call this number, the one that I'm going to highlight here. Let me call this n, and let's call the pink one r. So I can write same thing as n p r, and if I write a general formula for it, be n factorial divided by n take r factorial. That's a formula that we'd be using quite often if I ask you to arrange objects, letters, where the order was not important. Um, so, uh, so if I ask you how many ways can you arrange um, a letters from the word uh, horizon, let's say, if you took 4 letters at a time, then you know that horizon, just as another example, horizon. If I try to do this question, I have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. We have 7 letters, and we're selecting, let's say, 4 at a time. But the only problem here is, although we do that, we'd find that a few of those, few of the letters would be repeated. A few of the arrangements would be repeated. So you'd find that there are 2 O's in this question. That would mean that these arrangements would be repeated. So what we want to do is, we want to do 7p4. That will give us all the arrangements, and then we'll divide it by 2 factorials to get rid of the 2 times to get rid of these repeated arrangements with the 2 O's. So what I'm going to do is, I'm going to write 7p4 divided by 2 factorial just to get rid of those repeated letters. That'll give me 7 factorial over 3 factorial over 4 factorial over 2 factorial. Now you could do this in your own time, but I just wanted to move on to combinations right away. So what I'm going to do is, I'm just going to change the pen color. Let's talk about combinations. How are combinations different from permutations? Well, if you use the same example as before, you'll learn what the difference is between a combination and a permutation. Cap, if I asked you to select 2 letters at a time from the 3 letters, you'd find that your selections would be CA. So if you were to select 3 letters at a time, it will be CA, 2 letters at a time from 3 letters, CA, AT, and CT. That is pretty much it. That's your selection. You can't have any more selections because a combination is just a selection. A permutation is an arrangement. So in a selection, as it is a selection, in a selection, the order in a selection the order does not matter. The order does not, this is key, this is a key point, does not matter. So it doesn't really matter if we have the other arrangements as well. So I could say that we have CA, AC, AT, TA, CT, TC, but it really doesn't matter, because in a combination, when we're selecting 2 letters out of 3, the only selections I'll get is CA, AT, and CT, because the others really don't matter because they're repeated. Those combinations are repeated. So how do we write a general formula for it? So to write a general formula for a combination, what you would need to do is you have three letters here, and you need to choose just two. So similar to permutations, our notation here would be, or notation or symbol, mathematical symbol is C, and you have a superscript which is N, and R is the number of letters you're selecting at once. So that gives you, so let's say for this question, you'll get C, and you're selecting 2 out of the 3 letters. So it's 3C2, which is, and let's just write the general formula for this one. It's N factorial over N take R factorial over R factorial. So that gives me 3 factorial over 3 take 2 factorial over 3 take 2 factorial. So that gives me 3 arrangements, and that agrees with what we got. We got the 3 arrangements was the AI. Oh, sorry, there was no AI, there was AT and CT. That's it. So, in conclusion, we could say the difference between a permutation and a combination is that in a permutation, permutations combination. A permutation is an arrangement. A combination is a selection. In a permutation, the order matters. In a combination, the order does not matter. A quick question from AJ Sadler would be, how many combinations are there of two objects from 5 different objects? So two objects from 5. You could quickly write down the mathematical notation for it. So you have 5 and you're selecting 2. So you immediately write down the factorial notation, 5 factorial over 5 minus 2, 5 minus 2 factorial over 2 factorial, which gives you 5 factorial over 3 factorial over 2 factorial, which is 5 times 4 times 3 factorial over 3 factorial, 2 factorial, and 3 get cancelled. We are left with 5 times 2, which is 10. If you're wondering how I got 2 cancels with the 2 to give 2 on the top. So I get 10 as the answer. So there are 10 ways in which I can select 2 objects from 5, and so 10 ways of selecting 2 objects from 5 objects. Okay, so ladies and gentlemen, if you could, if you have the A.J. Sadler textbook, this is where you'd find yourself very comfortable doing exercise 10B now. So that would be your homework. Have a go through exercise 10B. Obviously, we're going to do it in class as well. But exercise 10B should be fine now. Have a good night. I'll see you tomorrow.